Hello learners, welcome back to the part 2 of hypothesis testing. We covered the p-value, significance level and what is hypothesis testing. Today we'll go in more detail and we'll also study about the type of errors and the practical applications of hypothesis testing. So remember we'll discuss the process first today of hypothesis testing. First we have to formulate the hypothesis, define what is H0, that is the null hypothesis, what is H1, that is the alternate hypothesis. So every time you have to define, like I gave you an example, the lead content in Maggie is less than 350. If it is less than 350, that is your null hypothesis. Whereas if it is more, it becomes your alternate hypothesis. And that was actually a test done by Nestle when there was a claim that Maggie has a lot of lead content. And if that hypothesis was to be found true, there would have been suspension in production of Maggie, right? Because that is a part of adulteration and which can be seriously injurious to health. Now, once you have given your formulated your hypothesis testing, you collect the relevant data for analysis. हम उसके बाद उसका data collect करते हैं. फिर हम एक threshold decide करते हैं अपना alpha का. Significance level को हम decide करते हैं. We decide the significance level, which is commonly 0.05 or 0.01. Most of the cases, 90 to 95%, it is 0.05. Then we conduct a particular statistical test, like we find the p-value or we do some tests, z-test, other tests. We do these type of tests and we find whether it is low or higher than the significance value. So we calculate the test statistics. Then we determine the p-value from that test statistics. Compare the p-value with alpha. So suppose if you have given a p-value of alpha of 0.05 and your p-value comes as 0.06, so it is more than alpha, right? So then you will fail to reject your null hypothesis. Whereas if the p alpha is 0.05 and p-value comes as 0.01, which is less than alpha, so you will reject your null hypothesis. So based on this comparison, you will draw the conclusions of your result. Then you communicate your results effectively, that you are either rejecting your null hypothesis or you are failing to reject your null hypothesis, right? Then you iterate and refine. You can again keep on refining and iterating this particular process to test again and again with maybe a set of new data or a new significance level as well. So now we'll discuss errors. What is error, right? When we are doing this process, there is a possibility of having an error. So what is a type 1 error? So type 1 error occurs when the null hypothesis is true, but we fail to reject it. That is, reject H0 when it is true. So the null hypothesis was true, but we have rejected it. Remember, if we are rejecting something, it should be false, but sometimes an error can be made and you reject a null hypothesis which was actually true. So that is a type 1 error. So probability type 1 error is denoted by usually 0.05. So only 5% or 1% of chance that error is called the level of significance of hypothesis test. So if the defendant is innocent of murder but still receives a death penalty, so you were saying that he is innocent, but you reject it, you give him a death penalty, whereas he was actually innocent. So you have done a type 1 error. So the probability should be extremely low, around 0.01, to ensure that defendant, if found guilty beyond a reasonable doubt, in contrast to civil trial involving car accident, large margins, the probability is this. So basically this is a significance level which you can give at very low, so that once you are ultimately sure that yes, this person is definitely a criminal, then only you give a very then only you give him a punishment and you reject the null hypothesis. So if you keep the significance value very low, then there is very less chance that you will make a mistake. It is very less likely that it will be less than 0.01 and still he will be innocent, right? So you keep this threshold very low so that you are not giving a wrong innocent person a wrong conviction, right? Whereas if it is known that if it is a car accident damage, which it is very known that if a person is driving a car, he would have definitely committed that crime, and there is no suspense around it or nothing to do with that. So in that one, you can have a higher significance level that okay, if this person was found driving, that means he is guilty of that car accident, right? So it can be acceptable, and this deciding the significance level can reduce these chances of type 1 error. Then opposite to that is type 2 error. You fail to reject a null hypothesis, but it was actually to be rejected. So it is denoted by beta. So in this case, a criminal is guilty, but the jury acquits him. So just imagine a criminal roaming around because he was adjudged as innocent, right? So this is the most serious error you can make, and let a murderer walk through. So you have to be very careful while choosing your results, whether your it should not be either type 1 or type 2 error. In both of the scenarios, it is gives the wrong result to your hypothesis, right? So I hope you understood the difference between the type 1 and type 2 error. Now, there are some practical applications in which hypothesis testing can be used. A new drug improves the patient's recovery time. So there is a new drug launch, new medicine launch, which improves the patient's recovery time. The null hypothesis is drug has no effect. The alternate is drug reduces the recovery time. So if you conduct a clinical trial and analyze the data, we may reject the null hypothesis saying that the drug is effective. So if the p-value comes less than alpha, then you will reject the null hypothesis and say that drug is effective. Whereas if the p-value comes greater than alpha, if the alpha was 0.05 and p-value comes as 0.08, so that means you will fail to reject the null hypothesis and you will say that drug has no effect. So this is how the null hypothesis has to be formulated, and then you have to take out the outcome for पर्टिकुलर एप्लीकेशन. तो यहाँ पे हमने क्या देखा कि अगर हम देखते हैं कि उसका जो पी वैल्यू है वो सिग्निफिकेंस लेवल से कम है, तो हम उसको नल हाइपोथेसिस को रिजेक्ट कर देते हैं दैट ड्रग हैज नो इफेक्ट. तो अगर इफेक्ट नहीं होगा इसका मतलब ड्रग हैज इफेक्ट एंड इट रिड्यूसेस द रिकवरी टाइम. वेयर अगर हम ये देखते हैं उल्टी तरफ कि अगर पी वैल्यू उससे कम नहीं उससे ज़्यादा है, तो इसका मतलब कि हमारी नल हाइपोथेसिस सही थी, ड्रग हैज नो इफेक्ट, राइट. तो यहाँ से हम देख सकते हैं कि इसका एप्लीकेशन कितना ज़्यादा है. ये हम इंडस्ट्री में यूज़ कर सकते हैं या मेडिकल इंडस्ट्री में ऐसे यूज़ कर सकते हैं कि हम कह सकते हैं वेदर अ पर्सन हैज़ कैंसर और नॉट, we can even do that hypothesis. But then you have to be very careful again when you are doing that hypothesis and you are finding your result, because if you say that a person does not has cancer and if he actually has cancer, that is very scary, right? That you are like detecting not cancer but he has cancer, which would have serious consequences. Whereas you cannot do the opposite as well, that is you are saying that person is having cancer whereas he does not have a cancer, then he has to start his medical treatment, which might be again bad for his health, right? Whereas the first scenario is more bad, so it is more required to reduce the type 1 error. But these are some other applications in which medical research also uses this statistical technique like hypothesis testing. Then you can use this for business decisions as well, redesigning a websites for a user engagement, right? So you would have seen when you go to Flipkart or you go to Amazon, there is a different set of like options or boxes which comes, right? Add to cart, sometimes it is buy now. So it is how the website design. Sometimes they give the price over there, right? Sometimes the thing is of say 1,000 rupees and they give 99.9 just to say that okay, the customer is not seeing 1,000. So that is also a technique to show your price, right? So all these are examples of like formulating and redesigning the user engagement. So you can have two different format of your user engagement, and then you can decide which one is better. So suppose if I have a new redesign and I say that it does not have any impact, that is my null hypothesis. Whereas alternate would be it is improving the user engagement. More users are coming to my platform now to buy things. So that would be the alternate hypothesis. And then we would test it, and again similarly we'll calculate the p and alpha to determine whether our null hypothesis was true or not. तो हम ये देखेंगे कि हमारे पास अगर ज़्यादा यूज़र आ रहे हैं तो हमारा एक्चुअल में जो हमारा p वैल्यू है वो अल्फा से कम होगा, क्योंकि हम रिजेक्ट करेंगे नल हाइपोथेसिस, क्योंकि हम बोलेंगे कि नहीं हमारे पास अब ज़्यादा यूज़र आ रहे हैं, तो वी विल रिजेक्ट द नल हाइपोथेसिस विच कैन बी डन वन p वैल्यू इज लेस देन अल्फा. बट अगर वो ज़्यादा हो गया इसका मतलब इट हैज़ नो एंगेजमेंट. तो यहाँ से भी हम इसको एक बिजनेस डिसीजन के लिए भी यूज कर सकते हैं. So these are some of the techniques in which hypothesis testing is used. Now some tips of doing hypothesis testing. So you have to very precisely decide what is null hypothesis, what is alternate hypothesis. Ensure that they are specific, testable and aligned with your research questions. So you should be aligned, right? It should not be okay which one is good, which one is better. You have to say whether it has some effect, it does not have effect, or whether the lead content is less than 350 or more than 350. So it should be opposite of each other. It should answer your question which you are trying to solve, right? Then you have to choose right kind of a test, whether you are doing a z test or there is a t test also. So you have to choose a right kind of a test which you are doing. You have to decide your significance level very cautiously, as we discussed, right? If you are think that okay I should have a lower significance level, if you think that probability can be on a lower side, still you want to actually like fail to reject the null hypothesis, then give a lower significance level. If you feel you have to be on a higher side, the significance level should be 0.05. If you feel that okay if it is like 0.04 also, then I should reject my null hypothesis, so then you should choose 0.05. So you have to select your significance level very correctly. So these are all the part of process, but this is something which you have to be very careful while you do hypothesis testing. Then you collect the adequate data, you have a good sample size of data which you have collected, and it is giving some power to like you can replicate, you can say okay this is holding good for 5,000, now it will hold good for 50,000 or 5 lakh as well. You cannot test only with 10 records, right? So you need to have a adequate data size. Even the sample size has to be adequate. So like it is at minimum it should be greater than 30 whenever you are doing a z test. So that is what is the adequate sample size. Then you understand the effect size, the practical significance of the observed effect. A small effect may be statistically significant or not practically relevant. What is the effect of your test? Then analyze and interpret your result based on the test statistics, p-value. Interpret the result in terms of your research question. So as I said, if the p-value is coming like 0.04, it is less than 0.05, and my null hypothesis was that lead content is greater than 350, whereas the p value comes less, so I will reject my null hypothesis. So the lead content is not greater than 350, right? So that is how I am answering my question based on what my p value and other test statistics comparison gives me, right? Then you have to report it transparently. You have to be very clear with your assumptions, with your p value and your findings and limitations, right? Then you have to learn for your from your errors, right? So if the type 1 error is coming and you feel it is coming more often, then you can reduce your significance level if it is coming higher. So you can play around with your significance level. You have to refine your process again and again. By refining your process means you can change your test, you can change your significance level and other things. So as we say that we learn from our mistakes, similarly if there are a lot of type 1 or type 2 error coming, so you have to refine your process and you have to be sure that neither you are getting a type 1 error ना type 2 error. So हम ये देखेंगे कि हमारा process उसका इफेक्ट साइज कैसा है, उसका रिजल्ट्स का हम इंटरप्रिटेशन कैसे कर रहे हैं. एक चीज होता है रिजल्ट्स आना, फिर उससे हम बिजनेस के लिए क्या इंटरप्रेट कर रहे हैं और उसको हम कितना ट्रांसपेरेंटली रिपोर्ट कर रहे हैं वो भी हम देखेंगे. फिर हम उसके एरर्स को कंपेयर करेंगे कि वो एरर्स किस टाइप के और उसको उस एरर की वजह से हम अपना सिग्निफिकेंस लेवल इंक्रीज डिक्रीज कर सकते हैं, अपने टेस्ट चेंज कर सकते हैं. तो ये पूरा प्रोसेस है हमारा हाइपोथेसिस टेस्टिंग का. आई होप यू ऑल एंजॉयड दीज टू videos or hypothesis testing, and I am enjoying a lot teaching and sharing my knowledge. Hope you are also enjoying. Do like, share and subscribe these videos with every one of your friends so that it reaches the maximum audience, right? And next we'll study SQL is something which is very important and which needs to be learned very nicely. So stay tuned for the next video on SQL. Thank you guys, have a great weekend.